logarithmic and inverse trigonometric functions. So basically 3 things: how to take the derivative of a logarithm, and that's this right here, it's 1 over x. And then this is like using the chain rule. If you have log of some expression, then it's 1 over that expression times the derivative of that expression. And then also the inverse trigonometric functions. This is inverse sine or arc sine, inverse cosine or arc cosine, and inverse tangent or arc tangent. The other 3 there are formulas for the other 3, but I'm not gonna really get into it here. If it comes up, then just look up the formula, and maybe for the exam you should probably just have those formulas just in case. Although, no, never mind. I'll probably avoid those. Okay, but there's other ones. Okay, so and then there's something else called logarithmic differentiation, and we'll get into that. Okay. So first of all, the derivative of the logarithm. Let me just show you how that comes about. So if we let y equal the natural log of x, okay, and then so y is natural log of x, and so the objective would be to find. So this one right here would be dy dx then. Okay, dy dx. That would be what we're looking for, and I'll show you that it's 1 over x. Okay, so if you do what I call exponentiate both sides, that is e is equal to e, but e to the, if these are equal, then e to the y is equal to e to the log x. But this is just x, right? So we get to there. Now, what you're going to do here is implicit differentiation. Okay, so the derivative, so we're taking derivative with respect to x. So the derivative of this side is e to the y times dy dx. Okay, that's this one. E to the y is e to the u, so the derivative is e to the u times du dx, and the derivative of this is just 1. Okay, so that means that dy dx is equal to 1 over e to the y, but we know that e to the y is x, so it's 1 over x. Okay, and so that's how you get this. So dy dx is 1 over x. That means the derivative of the natural logarithm is 1 over x. Okay, so let's go with exercise number 1, where you're differentiating this. Now for this one, we're going to use this rule here, which is just using the chain rule and applying it to what we learned just now. Okay, so g prime is equal to 1 over whatever's inside. Okay, so that's just this part here, times the derivative of this part. So the derivative of this is, okay, derivative of 8 is 0, and the derivative of t to the 6 is 6 t to the 5th. Okay, and so then now it's going to be 6 t to the 5th over 8 plus t to the 6th. Okay, and that should be the answer for number 1. Okay, let's go to number 2. Okay, now there's some things that will make your life easier, and that are properties of logarithms, okay? Okay, and now this one is we're just dealing with the natural log, but all logarithms do this. And we discussed this at the beginning of class. So if you have a product, then that's equal to the log of A plus the log of B. If you have a power, then you can bring the power out front, exponent out front. And if you have a quotient like this, then it's the log of A minus the log of B. Okay, log of the numerator minus the log of the denominator. Okay, so here what we have is we have a numerator and a denominator. So let's do this last property first. Okay, so that's, the numerator is 5y plus 1 squared. The denominator is, okay, now if it's a quotient, then you subtract. And I can write, instead of writing the square root, I'm going to write it raised to the 1/2. Positive 1/2, okay? So it doesn't say make this, it doesn't say keep the sign or whatever, because we're doing this minus, then this is fine. Okay, so the square root of something is equal to that something to the 1/2. Okay, and that's by this rule here. Okay, and then the next thing is we're going to use this rule here. And so this 2 comes down to the front. And the 1/2 comes down to the front. Okay, so that's our g of y. Now notice that I haven't even taken a derivative yet. So now it says differentiate. So now we take the derivative. Okay, so the derivative is 1 over whatever's there. But in this case, it's going to be 2 over that. Times the derivative of this, which is 5. So derivative of 5y is 5, derivative of that is 0. So times 5. Minus, and then over here, it's 1 over this, which is y squared plus 1, times the derivative of this, which is 2y. Okay, derivative of y squared is 2y, derivative of 1 is 0. So that goes right here. Okay, those are going to cancel. This is going to be 10 over 5y plus 1 minus y over y squared plus 1. Okay, so that's the answer to number 2. Any questions about any of this? Okay, let's move on then to the next exercise, number 3. Differentiating more logarithms. Okay, so here, we can go ahead and start taking the derivative. So it's 1 over whatever's here. Times the derivative of what's inside. Okay, so the derivative of this is e to the negative x times the derivative of negative x, which is -1. So that's just going to put a -1 up there. This one, let's do the product rule. Okay, so that's that. The derivative of x is 1. So that's plus e to the negative x. Ooh, look, I can't wait. Look, those are going to cancel. I'm going to be patient and wait for it. Okay, plus x times the derivative of this piece, which is, times -1. Okay, so then these are going to cancel. And also, I can factor e to the negative x out of the numerator. That leaves me with a negative x. And then I can factor e to the negative x out of the denominator. And then those guys cancel, or reduce to 1. And we just have negative x over 1 plus x. Okay, let's look at this one right here. We'll first calculate y prime. So it's just a log of something. So that means the derivative is going to be 1 over that something times the derivative of that something. Okay, so the derivative of 8 is 0, and the derivative of log is 1 over x. So this x I can take to the denominator. Like that. Or could be 1 over 8x plus x log x. Either way, this would work. That probably works also for the answer to number 1. Okay, for the second derivative, we just take the derivative of the first derivative. Okay, so now one trick that I should probably show you, or should I definitely show you, is that with the chain rule, you can actually get around ever using the quotient rule. So let me show you how that goes. So if I take this, for example, okay, that's like quotient rule or whatever you might say. It's got a numerator and denominator, but I can rewrite this as just I can write this 1 over x as x to the minus 1, and I can write this as 8 plus log x to the minus 1. Okay, and so instead of quotient rule, I got product rule all of a sudden. Hold on. This is y prime, sorry. Okay, now I can use the product rule on this. Okay, so the derivative of the first part, which is negative x to the negative 2, times the second part. Plus the derivative of the second part, which is negative. Okay, no, wait, plus, maybe more organized here. Plus the first one times the derivative of this one. Okay, and the derivative that's going to be negative. You got a negative come out, and this reduces by 1 power to minus 2. And then you multiply by the derivative of the inside part, which is 1 over x. Okay, so that piece is the derivative of the inside part. Right here, this 1 over x is derivative of this one. Well, all the 0 plus 1 over x. Okay, so the derivative of this piece, you got a negative 1 come down, and then you reduce this by 1, so negative 1 minus 1 is negative 2, and there you go. Okay, and then multiply the derivative inside. Okay, this one is just derivative here, so negative 1 comes down, and then minus 1 minus 1 is negative 2. Okay, so that's the second derivative. Probably want to simplify it. This is minus 1 over x squared times 8 plus log x. And then there's a minus here, so that's going to be minus. And then it's going to be 1 over, and this gives you x in the denominator along with that one, so it's x squared. And then this is 8 plus ln x squared. Now, if you want, you can get common denominator, because this is squared and that's not. That's the only difference. These are both the same. So if we multiply top and bottom by 8 plus log x, then all of a sudden we have the common denominator. And what is this? -8 plus 1, or -8 minus 1, that's minus -9 minus log x. Okay, that should work. Or if you want to pull the negative all the way to the front, that's fine too. There's negative all the way front here, so it's 9 plus log x. That would also work. Okay, any questions on that? Okay, let's move on to the next one. Okay, we're supposed to differentiate this and find the domain. Let's find the domain first, because that seems to be the more natural thing to do. Logarithms have to have this inside part has to be greater than 0. It can't be 0. It has to be greater than 0. It can't be negative either. Okay, so in order for the logarithm to be defined, it has to be, this has to be greater than 0. Okay, so we're looking at x times x minus 18 has to be greater than 0. So what I like to do is graph the zeros of this on the number line, or zeros of the numerator, zeros of the denominator. There's only a numerator here, so we're fine. And then look at each of the terms and determine what they are here. So this is negative here, and then positive there and there. This is negative there, and then positive there. Okay, and so the product is going to be positive here, negative there, and positive here. So that means that the domain is everywhere where it's positive. So it's these places right here. So that's negative infinity to 0, union 18 to infinity. Okay, that's going to be the domain. Now, you can make it do this symbol by just typing infinity, and this is in Webassign. And you can make it do that symbol if you just type union. Or you can look at the menu. You can find those in the menu. The symbol infinity, you can find that in the menu, and then also you can find this in the menu under sets. Union is under sets. Okay, so let's take the derivative. So that's 1 over x squared minus 18x. Is this just the natural logarithm times the derivative of the inside part, which is 2x minus 18. Oh, that's interesting. How was it? Okay, great. Any questions on that one? Okay, let's go to the next one. Find an equation of the tangent line to the curve at the point 80. Okay, so tangent line to this curve. So that means the derivative. So tangent, the slope is going to be the derivative. That's the slope of the line that we're after. So the derivative is just the logarithm. So the derivative is 1 over whatever is inside times the derivative of what's inside, which is 2x minus 8. That's the derivative. Okay, now it's at the point right here. So I always like to double check. You don't have to, but if you put an 8 in for x, those are going to cancel. So there's 64 minus 64, and then you have log 1, which everybody knows is 0. And so this checks out at 0. Okay. So, but anyways, we are after when x equals 0. So you want to put a, no, I'm sorry, x equals 8. Okay, so x is 8. You want to plug an 8 in here for x. And so that's 16 minus 8, that's 8. And then this reduced to 1, so it's 8. Okay, so the derivative is 8. That means the slope is 8, which means that we have y equals 8x plus b. But then we have this point right here. X equals 8, y equals 0. We want to plug those in. I'm going to plug those values in. Everything else is the same. And this is 64, so take it to the side, and b is negative 64. And y equals 8x minus 64. So that's the tangent line to this curve at that point. Okay, let's move to the next exercise, number 7. And here's where we do logarithmic differentiation. Okay, so with logarithmic differentiation, what you do is, well, you recognize here that this is pretty difficult to differentiate because you have the square root and then you have a quotient. And for sure, you could do it using previous methods. And supposedly, logarithmic differentiation is going to be a little bit easier. Okay, so what you do is you're going to start by taking the natural log of both sides. Okay, so log of y equals the natural log of all this. And I'm going to go ahead and change the, the square root to raising it to half. Okay, and then because now we can use the properties, the logarithmic properties that we talked about a few pages ago and also earlier in the semester, to bring this 1/2 out in front. Like that. And then use the quotient property to write this as the natural log of x minus 4 minus the natural log of x to the 8th plus 4. The natural log of the numerator minus the natural log of the denominator. And then this 1/2 distributes to both. Okay, 1/2 is just distributing here to both those terms. Okay, now we take the derivative. Over here, it's going to be 1 over y times dy dx. Okay, so derivative of natural log of y is just 1 over y. But if it's respect to x, then y is a function of x, and this is times, then the du dx is going to be dy dx. Over here, we have 1 over x minus 4 times the derivative of x minus 4, which is 1. And then here we have 1 over x to the 8th plus 4 times the derivative of x to the 8th plus 4, which is 8x to the 7th. Okay, so now I'm going to take this 1 over y, I'm going to take this to the other side of the equation. Actually, you know what? I'm going to take this, I'm going to do this. This 1/2 right here, I'm going to take that to the denominator, and it's 2x minus 8. Okay, this one reduces that to a 4, so it's 4x to the 7th over x to the 8th plus 4. and that's all multiplied by y. Okay, now this is our y actually, and so I'm going to just put that in right there to finish off the problem. And this is how I'm going to put it into Webassign, or actually how I put it into Webassign. Okay, so I ended up going right there. Okay, and this should be the exercise. This is the answer. So this y, which is this, it just gets replaced with that. So now I have dy dx all in terms of x's. Oh, it's all in terms of x's. Okay, so that's logarithmic differentiation. Here's another example of logarithmic differentiation. Now this one is pretty hard to do if you didn't use logarithmic differentiation. It's going to be pretty challenging. Okay, so here, logarithmic differentiation, that means the first step is to take the natural log of both sides. So it's the natural logarithm of tangent x to the 8 over x. Okay, now we can use the property here. This piece, the power property, this piece goes out in front. So we have 8 over x times the natural log of the tangent x. Okay, and in anticipation, because like I said, I like to avoid using the quotient rule, I'm going to write that as x to the minus 1. And now we're going to take the derivative of both sides. So this is 1 over y dy dx. That's that one. Here, it's product rule, so take the derivative of this first. That's negative 8 x to the minus 2 times this term. Plus this term times the derivative of this term. Okay, so the derivative of this term is 1 over tangent x times the derivative of tangent, which is secant squared x. Okay, so the derivative of tangent is secant squared. Okay, so this is just putting that there, and that's the derivative. Okay. So now I'm going to bring this 1 over y to the other side. And here I can rewrite this as negative 8 natural log of tangent x over x squared. I'm rewriting this x to the minus 2 as a 1 over x squared. And then this one is 8 secant squared x over x tangent x. And then we have this y right here. Okay, so this y ended up over here. And then, just like the previous problem, I'm going to replace this y with the original. to replace with that. So tangent to the 8 over x. Okay, that should work. That's for your answer in Webassign. Okay, any questions about this? Okay, let's move on to the next one. Okay, so the next one is we're going to look at these inverse trigonometric functions. So just for an example, let me show you this one right here. Okay, so if we let y equals inverse tangent of x, so the inverse tangent is actually an angle that makes things work. And so if you take the tangent of both sides, then all this just becomes x. So tangent y equals x. And then we do implicit differentiation. This is the secant squared of y, and this is 1. No. Secant squared y dx dy dx by the chain rule, and that's 1. Okay, so that tells you that dy dx is equal to 1 over secant squared y. Okay, but then you're like, Brother Hurst, it says it's 1 over x, 1 plus x squared, not secant squared y. Okay, now this requires a second part to explain. What I'm going to do here is I'm going to draw an angle here, and this angle will be y. Oops. Okay, because inverse trigonometric functions, the inverse tangent of x is an angle. Inverse sine is an angle. Inverse cosine is an angle. Inverse or arc sine, arc. This is also arc tangent. Those are all angles, or can be thought of as angles. It's probably the most natural thing is to think of them as an angle. Okay, now it's the angle such that its tangent is y. I mean, its tangent is x. I'm sorry. So the tangent of y is x. That means that we could make this x and that 1, and then this angle would have a tangent of x. And then this right here is the square root of x squared plus 1. Okay, now the secant of y, which is 1 over the cosine. The cosine is the adjacent over the hypotenuse. The secant is the hypotenuse over the adjacent. So the secant is the square root of x squared plus 1. Okay, and so what I'm going to do is I'm going to put this in to there. Okay, and so that gives me 1 over the square root of x squared plus 1 squared, which is 1 over 1 plus x squared. Okay, so that's the derivative of the inverse tangent of x is this. And similarly, you could do the same thing and get the inverse cosine and the inverse sine. You do those. Okay, so that's how you get those. And we're going to use them to find some derivatives. So first of all, we're going to find this derivative here. It's the inverse tangent of this. So first of all, it's going to be 1 over, let me rewrite this. Instead of the square root, I'm going to write it as x minus 8 to the 1/2. That helps things a bit. Okay. Okay, so it's going to be 1 over, okay, so here's the tangent right here. So it's 1 over 1 plus whatever's inside squared times the derivative of inside. So that here we're taking the derivative of this. Like that. So that's the derivative. Okay. This is 1 plus, and when you take the square root and then you square, you get x. You get the original thing back. That's x minus 8. Okay, and that's all times, there you got a 1/2, and you have this right here, which is 1 over the square root of x minus 8. Okay, and so when the dust settles, you've got this 2 here. This right here is x minus 7, and this right here is the square root of x minus 8. Okay. So that's the derivative of the inverse tangent of the square root of x minus 8. Okay, and then the next one, number 10, this is actually the last exercise. Like I said before, this is, the inverse tangent can also be written as, inverse sine or inverse of whatever can also be written as arc. Okay, so that's arc sine. So you could see arc sine, or you could see just inverse sine like this. Okay, so let's go ahead and do this one. Let's do orange. Okay, so the derivative, you got e raised to something. So the derivative is just itself. Just copy everything down, the whole thing down, e to the whatever, the whole e to whatever, times the derivative of this. So now we're looking at just the derivative of arc sine of z to the 8th. Okay, which is this, 1 over the square root of 1 minus z to the 8th squared, times the derivative of z to the 8th, which is 8 z to the 7th. Okay, so let me rewrite this in an organized way. I'll lead off with 8 z to the 7th, and then e to the arc sine of z to the 8th. And then the denominator will be the square root of 1 minus z to the 16th. Okay, z to the 8th squared is z to the 16th.